This demo is intended to highlight the 802.1QBG functionality. The demo shows how to configure virtual machines to connect directly to the physical network adapter via VEPA mode and the necessary steps to use the 802.1QBG to configure the physical switches. The setup consists of two System X HS22 blade systems running Red Hat Linux 6.1 with KVM support enabled. The HS22 blade systems are connected to a VEPA and 802.1QBG enabled IBM switch. Each VM is defined by its VSI profile. Based on this profile, the switch will associate the VM and apply the corresponding defined network rules. The VSI profile contains the VSI type ID and a unique instance ID. Let's briefly go over the topology and VM migration procedures through this PowerPoint. In the topology, each server has one VM configured and both the VMs have the same VSI type ID. The servers are connected to port 13 and 14 of the IBM switch. On starting VM 100, it gets associated to the switch on port 13. Similarly, VM 200 gets associated on port 14. At this point, both the VMs are added to the same VM group and VLAN as they have the same VSI type ID and traffic can flow between them. The next step is to migrate VM 100 from server 100 to server 200. In order for this to happen, first VM 100 starts on server 200 and the switch will relearn the association on port 14. Next, VM 100 shuts down on server 100, clearing the previously associated entry on port 13. This completes the migration process. Once the migration is complete, the traffic resumes between the two VMs using the reflective relay capability enabled on the switch. Let's now move to the actual demo setup. I am now on server 200 and I have opened the Virtual Machine Manager tool. From this, I can view all the servers and all the VMs. Let me first open VM 100. On selecting the NIC menu, I can see that there are two sections. One is the virtual network interface, where I select the host device, which is the direct interface or the MAC VTAP interface. The second section, the virtual port, you can configure all the VSI profile parameters like manager ID, type ID, version ID, and instance ID. Now let's view the same VSI profile on VM 200. As you can see, both the VMs have the same VSI type ID, but they have unique instance ID. Now let me start VM 100. To the right of this server window is actually the switch console. So starting the VM will send associate messages to the switch, and from this console message we can see that VM 100 has been associated on port 13. I intend to run traffic between the two VMs using iPerf tool. VM 100 will be configured as the iPerf server. This has an IP address of 1.1.1.100. Now let me start VM 200 on server 200. You can see again a message which says this VM has been associated on port 14. This VM will be configured as a RIPERF client. This VM has an IP address of 1.1.1.200. You can see that the traffic between the two VMs has a bandwidth around 2 gig. Now let's view the switch configurations. There are two ways to view and configure the switches. One is the CLI option through the CLI console, which we viewed before, and this is the graphical interface called Blade Harmony Manager. Let's look at first the VSI type configurations on the switch. This window under Virtualization EVB VSI type shows you the VSI configurations on the switch. The most notable is the VSI type ID, which has been configured to be 100, the same as that of the servers. We can view this VM associations through the VSI table. As you can see, both the VMs are associated on port 13 and 14. Now on the switch, we can configure VMAP ACLs to rate limit the traffic. The VMAP ACL can be configured for permit, deny, and also based on numerous filter criteria. But in this demo, we will rate limit the traffic between the two VMs to around 30 Mbps. The idea behind this is to first apply the VMAP, verify its effect, and then complete a migration and check whether the VMAP action still holds. The VMAP policy will be dynamically applied on the VM group and need not be reconfigured after the migration. To configure the VMAP ACL, we select the VM group, which is 1, and then we modify. We attach the pre-configured VMAP to this VM group and hit apply. This should take a couple of seconds. Once the VM configuration is applied on the switch, we can see the traffic bandwidth between the VMs dropping to around 20 to 25 Mbps. Now let's do a VM migration of VM 100 from server 100 to server 200. And let's come back and view the VM console to check the bandwidth. So I select server 200 as my target destination and hit migrate. As you can see, VM 100 is currently paused on server 200 and it's now running. The source VM 100 is now shut down and both the VMs are now on server 200. Now let's go back to the VM console and check whether the traffic is being rate limited. As you can see, the traffic is still configured at 20 to 25 Mbps. Now we can view the VSI type information. VSI type associations, whether they have been relearned on port 14. As you can see, Both the VMs are now learned on port 14. Now this takes us to the last part of the demo, where we will be shutting down the VMs. Shutting down the VM will initiate a deassociate message on the switch and it would clear all the VM entries that were learned. You can see through this console message that VM200 has been dissociated from port 14. Now let me shut down VM100. You can see the second console message. This will clear all entries on the switch. This brings us to an end to the short demo. Hope it was informational and it provided insight into the QBG implementation. Thank you.